Good evening, friends. Today I will tell you about sperm preparation techniques. Why do we need it? Before we must consider what we must do to prepare sperm, we must consider why we must do it. We must understand that under in vivo conditions, human semen would not find itself in the vicinity of any ovulated egg in the investments of the fallopian tubes. During its journey from the site of an insemination, the vagina, through the challenging and hostile environment of the female reproductive tract, those sperm with the greatest fertilization potentials are actively selected for those sperm with poor potential and the other non-sperm cellular and molecular components of the semen. By cervical mucus, potentially fertile spermatozoa migrate to the site of the conception and undergo the process of capacitation, gaining a hyperactivation state of motility and the acrosome reaction prior to finally making contact with the oocyte itself. The aim of any preparation sperm preparation procedure is multifactorial: to extract a sperm population with improved sperm motility, morphology, and DNA integrity. Second, to remove seminal plasma, non-sperm cells, and other non-beneficial seminal detritus. To permit normal sperm function, including capacitation without the induction of the acrosome reaction prematurely. To be time efficient and cost effective, to resist the magnification of reactive oxygen species, to be non-reproductive and have no detrimental short or long lasting effects on the sperm harvested or on subsequent embryo or fetal development. I will tell you about this sperm preparation methods. First, direct sperm wash. The simple means of removing seminal plasma without materially altering the characteristics of the sperm. The process of sperm wash is: add a volume of sperm wash media culture and a semen sample, then centrifuge at 1500 rpm for 5 minutes, then remove the supernatant and then add then add zero point 0.1 to zero point 0.3 ml of this wash media to the pellet. The sample you will take must be just double of the media, means if you take 0.5 ml of media, then 1 ml of sample is to be taken. Not more than 1 ml of media is to be taken. The next is swim up method. It separates sperm based on motility with migration of highly motile sperm into a clean and harvestable layer of culture media for insemination. In this process, take 0.5 ml of semen in a test tube and 0.5 to 1 ml of flush media is to be dropped into the test tube. Flush media is a sperm wash media. A layer of sperm wash media onto the semen will be observed. Keep the test tube around 10 to 15 minutes. The motile sperms will be harvested from the wash media layer, then put one drop of it on the slide and observe under the microscope. The third one is density gradient centrifugation. In this, the selection is done by density using colloidal silica particles to trap the low density cells where high density sperm with improved sperm functioning penetrate the column and form a pellet. The gradient medias are formed into two layers of different densities, high and low. Set up differential gradient density gradient column, usually either 90% or 45% or 80% or 40%. The process of density gradient is: take 0.5 ml or 1 ml of 80% gradient media, then add 0.5 to 1 ml of 40% of gradient media. The 40% of gradient media is to be dropped to make a layer without disturbing the 80% of media. And then 1 to 2 ml of semen sample is to be layered on the on the above the 40%. Then centrifuge at 1500 rpm for 15 minutes. Then discard the supernatant. Then add 1.5 to 2 ml of washed sea media. Then mix well with the pellet and centrifuge for 5 minutes at 1500 rpm. Then discard the supernatant and add zero point 0.2 to zero point 0.3 ml of sea media for swim up. By swim up or density gradient, eliminate immotile and dead spermatozoa along with exfoliated cells, cellular debris, and amorphous material. Sperm preparation by swim up removes seminal plasma and concentrates the most spermatozoa in a very small volume of sperm culture media. Sperm preparation by swim-up removes seminal plasma and concentrates the most motile spermatozoa in a very small volume of sperm culture media. However, the sperm yield is low in cases of oligozoospermic ejaculates with low motility. For this reason, swim-up is preferred for normozoospermic specimens. Conversely, density gradient centrifugation is usually preferred to process ejaculates with low sperm number, motility or morphology, as it allows the elimination of leukocytes and other organisms which are trapped in the gradient interface. Density gradient can be altered to optimize sperm recovery by decreasing the gradient volume, which limit the distance that the spermatozoa migrate, only by increasing the centrifugation time in cases of hyperviscous ejaculates. Like and subscribe, and if you have any question, then write your question in comment box.